In the last episode, we made a model of the expanding universe and predicted three distances. Because distance changes over time, we need three distances. Say at time t, a photon is emitted by a galaxy. As it travels, its wavelength will stretch, and so will the distance between the galaxies. The ratio of the old and new wavelength equals the ratio of the old and new distance, and that is 1 plus z, where z is the redshift. Now, the light itself didn't travel either of those distances. It traveled this distance, which is c times its travel time. So the three distances are the distance the light was emitted from, the distance the source is now, and the distance the light travels. As z goes to infinity, t becomes the age of the universe, and d emit becomes zero because everything's zero at the Big Bang. So that means at this point something interesting is happening. The distances are going from increasing to decreasing. You might be wondering how that's even possible. Well, if the universe expanded at a constant rate and everything got consistently farther apart, then there would be no turnaround. To learn more about this model and these parameters, check out episode 2, but there is no distance turnaround here. Our universe has an evolving expansion rate, and back here, the expansion was faster. Since z equals 0 is the present, expansion was faster in the past. A lot faster. To understand what's going on, let's look at the model, which puts galaxies 1 billion light years apart and then puts them in motion. They're going to move towards each other because we're going to go backwards in time. They move at HD, and then there's going to be a minus sign there. Now, we're going to put some light in the model, and that's going to move at c minus HD. So the same thing, but at the speed of light. So as the model goes, the photons will slow down because HD will encounters C, and then the light will be trying to move in one direction while expansion's pushing at the same speed in the other direction. So everything is going to move and converge back here to the Big Bang. If we watch this in reverse, so time's going forward, and single out two galaxies, we see that light is emitted from one galaxy, and then it turns around and heads in the other direction, and then if it's emitted from this galaxy, it'll reach the observer at the same time, from the same distance, but two different points in time. Watch again as the light starts heading in the wrong direction, but the expansive space slows down and allows it to move in the right direction. And it gets to the observer just as we expect. D emit is known as the angular diameter distance. So this point is the angular diameter distance turnaround. It's at z equals 1.6, where the recession velocity is c. The photon is stalled out until the expansion rate decreases. It's okay that light's moving at 0 because everything around it is moving at c. The angular diameter is how much of the sky in degrees the object takes up. If an object of the same size occurs at different distances, it'll appear smaller until it hits the turnaround, where it'll appear larger. And even though it goes smaller to larger, it always appears redder. So, we have the distance the galaxy is now, the distance the galaxy was when the light was emitted, and we have the light travel distance. D emit is the angular diameter distance. It reaches a maximum, then decreases, and things look larger after redshift 1.6. So, with all of that said, is any of this real? Ask Ethan says they actually appear to be twice as large as similarly sized galaxies only half the distance away. So this is a galaxy in a collection greater than redshift 10. If every large redshift has a lower redshift buddy that has the same angular diameter distance, z equals 10 is z equals 0.27. If we go looking for some galaxies at that redshift, we find out they are much, much larger. And this is known because when this is tested, the galaxy sizes don't follow the turnaround. This says without evolution. And that means we have to assume that as the universe evolved, galaxies evolved from smaller to larger in order for them to fit this blue line. Well, wait, are they really small and compact? Or did we just trick ourselves into thinking they are? And actually, they are just ordinary galaxies far, far away. Well, we should be able to find out pretty soon. So make sure to subscribe and you'll get updated when we find out more. What topic should I cover next? Have something to add? Leave a comment. Thanks for watching.